Good evening, students. I want to discuss the effect of temperature, pressure, surface area on the rate of chemical reaction, and perhaps also um, go ahead and take one or two examples to illustrate the effect of temperature, pressure, and surface area on the rate of chemical reaction. So our objective this evening will be describe the following as it affects the rate of reaction, temperature, pressure, and surface area. Um, let's start with temperature. When you increase temperature, the rate of reaction will increase. Why would the rate of reaction increase? The rate of reaction will increase because the particle will have more kinetic energy to collide faster. They will collide more frequently. They will collide with EA or more than EA, and there will be more successful collision and hence faster rate of chemical reaction. So at higher temperature, the rate of reaction is bound to increase because the molecule will have more kinetic. The emphasis is on kinetic. We have different types of energy: sound energy, chemical energy, light energy. So you have to specify which type of energy the molecules of the reactant will have. You must specify that at higher temperature, the molecule will have more kinetic energy. The opposite is the case. At lower temperature, they will have lesser kinetic energy. They will collide less frequently. They will collide with energy that is not equal to EA. There will be lesser successful collision and hence a lower rate of chemical reaction. Let's consider surface area. What do we mean by surface area? Surface area has to do with the amount of surfaces available for collision during chemical reaction. A lump of a chemical will just have a surface. A surface is not enough to increase the rate of reaction. But when you break down the lump into smaller particles, there will be many surfaces. So a particle that is powdery has millions of surfaces. That one we say larger surface area or higher surface area. Rate of reactions will occur faster because there are many surfaces that will collide, many surfaces of the chemical reaction, many surfaces of the particle that will collide. But when you have only a lump or two lumps, the surfaces that will collide together are far apart, and there will be lesser or slow rate of reaction because the surfaces hardly collide because they are far apart. But when there are many surfaces, reaction will be faster. So when you have just lumps, fewer lumps, we use the word smaller surface area, and the time will be longer. So when you are given time and powder, lumps, and small particles, you should know that the one of powder will take the smallest uh, amount of time. The one of lumpy particle will take the largest amount of time because reaction is slow. That is very important. So rate of reaction occurs at either lower surface area or higher surface area. When it occurs at higher surface area, it is usually faster. So therefore, at higher surface area, there are many available surfaces to collide. Particles will collide more frequently. They will collide with EA or more than EE, and there will be more successful collision, and hence the rate of reaction will be very faster. But when you are in lumpy, like the first diagram here, when they are in lumpy form, as in the case of this one, in lumpy form, the reaction is very slow. We say that is the lower surface area because lumps will not allow, the lumps are not many. So they'll be far apart, and so they will hardly collide. And so it will the time to react will be very, very long. So that will be slow rate of chemical reaction. The next slide. Now, this slide can help us to understand what we mean by surface area. If you look at this, you see lumps. When you have lumps, rate is slow, e.g. 5 minutes. Small particles, not as slow as lumps, e.g. 3 minutes. Powder, very fast because there are many surfaces, e.g. less than a minute. So the powder, the time will be lesser, so very fast, or the fastest rate of reaction. The next slide will help us to understand the another thing again. Pressure. What do you mean by pressure? Look at the two diagrams here. The two diagram here can be used to illustrate what we mean by pressure. Pressure and concentration actually mean the same thing, but pressure is for gases while concentration is for aqueous reaction. Now let's look at this one now. In this case, in this area here, you will see that in this area, you will see that the particles are more closer together because they have been compressed together. So at higher pressure, there is little space in the particles. So when the particles have little space, we see higher pressure. Because they are very close together, the reaction will be faster because there will be more collision. So at higher pressure, the first mark that you will score is that at higher pressure, the particles of the reactant are very close. So as I was saying, at higher pressure, the particles of the reactant are very close together. Because they are very close, they will collide more frequently. Because they are very close, there will be more collision or more successful collision. And then when they will collide with the minimum activation energy or more than the activation energy, thus making reaction to go faster. So higher pressure makes reactions to go faster because the particles are closer together. Particles collide more frequently, and the particle collide with EA or more than EA for successful collision. And there will be more successful collision, therefore, rate of reaction will be faster. But at higher pressure, the particles are far apart and they will collide